So hello everyone. Today we are going to solve another question on LeetCode, and the question is best time to buy and sell stock. So what this question is saying? So we have given an array prices, and the price where the prices of I is actually representing the price of a given stock on ith day. For example, the 7 is representing the price of the stock on first day. This 1 is representing the price of the stock on second day, and so on. Now what we have to do? We have to maximize the profit. And how we will do this? So let's say first we have to buy the stock. So let's say we are buying the stock on one day. After that, in future, we have to sell this stock. So first we have to buy this stock. After that, we have to sell this stock. And we have to make sure that the profit after selling this must be maximum. So this is what it is saying. We have to maximize the profit. And after that, we have to return this maximum profit out of it. So let's try to solve this. So this is the example we have taken to solve this. So the first approach is, let's say, here, from here we are starting. Now for this element, 7. So this is basically representing the price of the stock on first day. So what we will do, for each element, we will traverse the whole array and try to find the maximum profit out of it. For example, let's say we have buy the stock on this first day where the price is equal to 7. Then on which day we will sell this such that we will get the maximum profit. Now, as we can see, this 7 is the maximum element in this whole array. So whenever we will try to sell this, it doesn't matter because it is not going to give us the maximum profit as it is the greater element inside this array. So let's move forward. Now we will be at this where second day where the price of the stock is equal to 1. Now let's see if we will try to sell this on this fifth day, then on fifth day the price of the stock is equal to 6. So the maximum profit out of it is equal to 5. So this will be our maximum profit. So for each element, we have to check with each and every element in this array. So the time complexity to solve this question is O of n square, that is quadratic time complexity. Why? Because for each element, we are traversing each and every element and try to get the maximum profit out of it. So this is the time complexity for this approach. But in worst case, this solution will not get accepted and it will throw time limit exceeded error. Now let's try to understand why it will throw time limit exceeded error in worst case. So as if we will see constraints here, then it is saying that the length of this array prices varies from 1 to 10 to the power 5. So in worst case, the number of element in this array is equal to 10 to the power 5. And as we are designing this solution in O of n square, then if number of elements are 10 to the power 5, so 10 to the power 5 whole square is equal to 10 to the power 10. So these much of iterations will execute if we will try to execute in worst case using this O of n square algorithm. But this solution will not get accepted as it will only check for 10 to the power 9 iterations. If there are more than 10 to the power 9 iterations, it will simply got fail and throw time limit exceeded error. So here basically we have to reduce this time either to O of n log n or to O of n. So let's try to do this. So let's try to design another algorithm where we can decrease the time complexity. So the second approach is here we will start from this last element and each and every time we will try to predict the future. So what we will do, as we can see in this part of the array, this is the greater element. If we will see this part of the array, this will be the greater element. So what we will do, we will simply store this greater element into a variable. So here greater element is equal to 4. Now we will start traversing back from this second last position and we will go till 0th index from here to here. Okay. So let's start traversing back from this position. Now Let's say if we are buying the stock on this day, then the price of the stock on this last second day is equal to 6. Now, if we have to sell this in future, then to get the maximum profit, we have to check for the largest element after this element. We have to check for the larger element after this element. And as we are already tracking this larger element into this greater element, so here we can simply compare it with the help of it. So here we are simply predicting the future. We already know that which is the greater element in future, and on the basis of which we can predict that what will be our maximum profit in the future. So what we will do, we will simply try to buy it on this day, and we will try to maximize this in the future. So as we can see that after this element in future, there is no greater element than this. So it will never give you maximum profit. So what we will do in that case, we will simply replace this element with this greater, as now the greater element is 6, and it is not going to give you maximum profit in future. Now this greater element is 6. Now we will move backward. We will come here at this place. Also, we are taking a variable maximum profit to store the maximum profit into it. Now we are at this position. Now, as we know that in future, the greater element will be this 6. Greater element will be this 6. So if we will buy the stock on this day and we will try to uh, sell this on this 6th, on this 5th day, where the profit is 6, where the price is 6, then the maximum profit will be 6 minus 3, that is equal to 3. Is this 3 greater than this maximum profit? Yes, this 3 is greater than maximum profit. So we will simply replace this with 3. Now again, we will move back. Here we have 5 on third day. So here we are buying the stock on third day, and let's try to sell it in future. So in future the maximum price is 6. So if we will sell it in future, then the profit will be 1. And is this one greater than this maximum profit? No, this one is not greater than maximum profit. So we will simply not consider it and move backward. Now we are on second day. Here the price of the stock is 1. So if we are trying to buy this on the second day and try to sell it in future uh, on this 5th day, then the maximum profit will be 6 minus 1, that is equal to 5. Is this 5 greater than this 3, that is greater than this maximum profit? Yes, 5 is greater. So we will simply keep 5, replace 5 with it. Okay, after that we will move backward. We will come here. Now, if we will buy the stock on this day where the price is equal to 7, then whenever we will sell this, we will never get maximum profit out of it because it is the greater element. But now it also replaces this greater element because now this is the greater element. So here what we are doing, we are just predicting the future that when we will get the greater element, and for each and every element, we are trying to get the maximum profit, and we are just replacing the maximum profit, and finally we have got this maximum profit as 5. So now, why this is a DP problem? Let me discuss this. So here, what we are doing, we are just memoizing the greater element. We are just memoizing the greater element to predict the future. Then that when we will sell this to get the maximum profit out of it. So this is the technique of dynamic programming that is known as memoization. Here we will memoize the result, and whenever we need this, we will simply use this. So this is memoization technique. That's why this is a dynamic programming problem. Okay, let's try to write pseudocode for this. So let's say we are implementing a function where we have to implement this function maximum profit, and we have given an array of prices where prices of I is representing the price of the stock on ith day. Okay, now simply we will take a variable that is maximum profit, which will initially equal to 0. Initially, the maximum profit we have is 0. After that, we will simply extract the length of this into a variable n. So n is equal to prices dot length. After that, we will start from here, from second last position, and we will store this element into a greater variable. So Up to this position, the greater element is 4 itself because there is only single element up to this part of the array. So we will store it in greater variable. So greater equal to nums of n minus 1. After that, what we will do? Uh, we will simply loop from this second last position and we will go till 0th index. So simply loop through it for int I equal to n minus 2 because this n minus 2 is the second last position and I greater than equal to 0 and we will move till the 0th index. Now what we will do? Simply we will take a variable that is profit which will keep the track of profit at every step and the profit is equal to 0. Now we will check if the prices of the I is greater than the greater element. Now in that case what we have to do? If the prices of the I, that is this 6, is greater than the greater element, at this time greater element is 4. So what we will do? We will simply replace it with replace this greater with this prices of I. So we will simply do greater equal to prices of I. Else what we will do? Else profit equal to prices of I, profit equal to the greater element, that is the greatest price in future, minus the prices of I. After that what we have to do? We have to check if this profit that we are getting is greater than the maximum profit. Then in that case, simply we will replace this maximum profit with this profit variable. So in that case, maximum profit equal to profit. So this will be our final solution. Now, if we will analyze time complexity and space complexity into it, then the time complexity, as we are starting iterating from this second last position, and we are iterating back till this 0th index. So we are iterating the whole array. So in this case, the time complexity is equal to O of n, that is linear time complexity. So basically here we have solved this in linear time complexity. Previous approach we have discussed that was O of n square. Now we have decreased this time complexity from O of n square to O of n. And the space complexities, as we are not taking any extra space, these are simple variables. So the space complexity is O of 1, that is constant space complexity. So let's try to implement this. Now what we will do? First, we will take a maximum profit variable. Initially it is equal to 0. After that, we will extract this price length into a variable and we will store the last element into this greater variable. So it is equal to prices of n minus 1. Now we will start traversing from second last I equal to n minus 2, I greater than equal to 0, I minus minus. Now what we will do? We will simply take a local variable here, that is profit, which will track a profit at each step. After that, if we will check whether this price of I is greater than greater. If it is, then simply we will replace this greater with prices of I. Else what we will do? Else simply we will store profit equal to greater minus prices of I. And at last, we will check whether this profit is greater than maximum profit or not. And if it is greater than maximum profit, so we will simply store this maximum profit as profit. We will simply replace this. After that, finally, we will return the maximum profit from this. And as it is saying that the length varies, the length of this array varies from 1 to 10 to the 5. So we have to handle the base case also. So If the size of this array is equal to 1, we will simply return 0 from here. Now let's try to run this, and it is accepted. Let's try to submit this, and it is submitted successfully. So that's all for today. Thank you.